Welcome to the Automation Lifecycle Management module. Here you'll learn how to set clear automation objectives, pick the right processes to automate, and align your automation tools to fit your existing IT infrastructure. Plus, we'll guide you through choosing the best tools to meet your needs. We'll also dive into important topics like lifecycle management, troubleshooting, and logging. We will discuss tools like BigIQ, BigIP iHealth, and external monitoring and logging solutions. In this part, we'll explore how to operationalize automation in an enterprise environment. By the end of this video, you'll have a solid understanding of how to define your automation objectives, select and prioritize processes, integrate automation into your existing IT infrastructure, and evaluate the right tools for your needs. Before starting automation projects, it's important to capture why you're doing it and what you want to achieve. Setting clear goals helps you stay focused and choose the right tools and processes. Think about your goals from both technical and business perspectives. From a technical angle, capture your challenges. Those could be keeping BigIP configurations consistent across different environments, or update app certificates automatically across X number of BigIP instances. Automation goals can be around helping reduce manual errors, making configurations more consistent, or speeding up deployments. From a business perspective, think about how automation can help you meet strategic goals like reducing risk, inconsistent config, scaling operations, cutting costs, or making services more reliable. For example, automating the onboarding of F5 BigIP devices can save time when bringing new services online and ensure high availability through automated health checks and recovery processes. By setting clear objectives from both technical and business angles, you build a strong foundation for a successful automation strategy that aligns with your organization's goals. Here are 5 key areas to consider when investigating automation opportunities. Instance onboarding. Automate the process of adding new BigIP devices to your network to reduce setup time and minimize human errors. Configuration management. Keep your BigIP configurations consistent and up to date across environments with automated configuration scripts. Application deployment. Simplify and speed up the deployment of applications by automating the creation and updating of virtual servers, pools, and monitors. Health monitoring and self-healing. Automatically detect issues with BigIP devices and services, and trigger corrective actions without manual intervention. Backup and recovery. Automate regular backups of BigIP configurations and enable quick restoration in case of failures. These areas represent practical and impactful use cases for automation, helping you improve efficiency and reliability while reducing the risk of manual errors. How do you identify which tasks and processes to target for automation? How do you capture potential complexities or risk of automation versus the potential risks? Have you done a cost-benefit analysis to make smart choices as to what to prioritize for automation versus perhaps continuing with a manual approach? This part covers assessment of risks, planning for challenges, and stakeholder communication to ensure alignment before and during the automation project. First, how do you prioritize what to automate? Not every task should be automated, and some processes just aren't worth the effort. Start by looking at your current workflows and find those tasks that are repetitive, take a lot of time, and prone to errors. Those tasks that encompass processes with the biggest impact on efficiency are the best candidates for automation. Once you identify these processes, assess their complexity and the potential benefits of automating them. Break down the tasks into smaller components and analyze if automation impacts outcomes of reducing repetitive and time-consuming tasks, while helping reduce errors and accelerate time to value for your and other teams. Many organizations run a quick risk assessment to understand potential challenges and failures that could arise from automation. Consider scenarios where automation may introduce vulnerabilities, issues with storing admin credentials or managing secrets, or configuration errors. A commonly overlooked risk is the lack of sufficient rollback procedures. Automating critical processes without proper error handling and validation checks can lead to disruptions and outages. To mitigate these risks, make sure to plan for and incorporate comprehensive testing and validation before rolling out automation into production. This can include automated unit tests, integration tests, and performance checks to catch issues early. Use pilot projects to test automation in a controlled environment, simulating real-world scenarios and measuring outcomes. This way, you gain insights into potential failures and their impact, allowing you to fine-tune your automation scripts for reliability and robustness. Another tool in your assessment is a cost-benefit analysis. Start by estimating the development and maintenance costs of automation, including resources, time, and skills needed. If looking at AI, for example ChatGPT, to help accelerate development, also consider costs of integration, troubleshooting, or handling conflicting or inconsistent instructions that sometimes result from AI consolidating different resources to provide its automation guidance and scripts. Then compare these costs to the potential savings in time and effort once the automation is in place over a specific period of time. There will be a break-even point and an upside in automating processes for systems that have a longer time span, so that is also a factor for your consideration. Lifecycle management of automation assets, such as playbooks, scripts, and even Git repositories, also factors into the ongoing costs of automation. All that considered, the best measure of the upside of scaling operations through automation is analyzing the frequency of the task performed. Automating high-frequency tasks of low complexity usually yields the most significant return on investment. On the other hand, automating rare or highly complex tasks may not be worth the effort. For example, automating routine configuration updates or daily health checks on big IP systems can significantly reduce manual workload, while automating complex and infrequent failover scenarios may turn out to be cost-prohibitive or unrealistic to automate and maintain. Evaluating the complexity, frequency, and impact of the tasks targeted for automation helps you make data-driven decisions about where to apply automation effectively. Lastly, involve stakeholders to understand pain points and identify high-impact areas. Communication is key to ensuring that automation efforts align with real-world needs. Engage with network engineers, application teams, and IT operations to gather insights on which tasks consume the most time or are prone to errors. Sometimes, input from different teams can reveal processes that are more suited for automation than initially thought. Make sure that everyone understands the potential benefits, such as increased efficiency and reduced manual errors. Keeping stakeholders in the loop helps build support and collaboration, ensuring that automation projects are well received and properly integrated into existing workflows. By balancing technical feasibility with business value and maintaining clear communication, you can create a well-prioritized automation plan that maximizes benefits while minimizing risks. Picking the right automation tools makes your F5 Big EP automation easier and more reliable. There are many tools out there, each with its own strengths and ideal use cases. Let's look at the most relevant ones. Terraform is great for setting up infrastructure and managing resources as code. It's particularly useful for greenfield deployments where you build new environments from scratch. You can define infrastructure as code with reusable templates, making it easy to scale up and replicate configurations. Automating initial big IP deployment, configuring new virtual servers and instances like VLAN setups, IP addressing, and security policies helps ensure consistency across environments. Terraform's state management feature also tracks changes, making rollbacks and version control straightforward. Maintaining Terraform scripts in a Git repository and evolving your automation toolchain with orchestration tools like Jenkins or GitLab CI/CD will create a strong long-term stance for automated deployment and testing. Ansible is excellent for configuration management and orchestration. It allows you to automate tasks like creating and updating config of virtual servers, managing pools, setting up monitors, and handling traffic policies. Ansible's agentless architecture makes it easy to push updates and changes to Big IP devices by leveraging the official F5 Big IP modules, giving you precise control over configuration settings. Ansible can also work with F5 AS3 to deploy application services using declarative JSON-based templates. This combination of modules and AS3 provides both low-level control and high-level service orchestration. Additionally, Ansible playbooks can be integrated with CI/CD pipelines like Jenkins or GitLab to automate deployments as part of a continuous integration and delivery process. Chef and Puppet are popular for configuration management and provide similar functionality to Ansible. However, they require agents to be installed on target devices, which may not always be desirable. Orchestration and CI/CD. To achieve end-to-end automation, consider integrating tools like Jenkins or GitLab CI/CD into your workflow. They help manage the entire deployment pipeline, including testing, validation, and monitoring. When evaluating tools, consider factors such as community support, integration capabilities, documentation quality, and compatibility with your existing environment. Sometimes a combination of tools is the best approach, as it allows you to cover different aspects of automation with the most suitable technology. By carefully selecting the right tools for your use case, you ensure a more efficient and reliable automation process that fits seamlessly into your IT environment. Once you have your objectives and processes identified, it's time to think about integration. Getting your automation to work well with your existing IT setup is important for keeping everything running smoothly. Start by evaluating how your chosen tools will interact with your current systems, including monitoring, logging, and management platforms. For example, when using Ansible with BigIP, consider integrating with centralized logging systems to capture configuration changes and performance metrics. This helps with auditing and troubleshooting automated tasks. Similarly, if you are using Terraform, ensure that your state files are stored in a version-controlled and secure location, local store, NFS, or S3, to enable collaboration and state tracking. When setting up automation, it's essential to make sure your BigIP REST APIs are accessible and properly secured. These APIs are at the core of how automation tools like Ansible and Terraform interact with your BigIP devices. Double-check that API endpoints are reachable and use authentication methods that keep your system secure. Make sure to handle errors timely to avoid disruptions if something goes wrong. Proper error handling will help maintain stability and provide useful information for troubleshooting. To maintain consistency, integrate your automation with orchestration tools, like Jenkins or GitLab CI/CD, to trigger automation tasks as part of your deployment pipeline. This way, any changes or updates are consistently applied and tested automatically. A successful integration strategy minimizes disruption and ensures that automation solutions complement your existing workflows rather than complicate them. By carefully planning integration points and maintaining compatibility with orchestration and monitoring tools, you ensure a smooth and reliable automation process. In this chapter, we will look at how Terraform and Ansible can be used together to automate the full lifecycle of BigIP systems and application services. This includes provisioning new environments, managing changes, and applying updates. We will also show how using infrastructure as code helps make the process easier to repeat, track, and manage. Let's start by looking at the automation lifecycle and how it applies to F5 BigIP management. The automation lifecycle in the context of F5 BigIP management includes tasks like configuring, managing, and optimizing the BigIP-based app infrastructure to ensure that it runs smoothly and performs well. The objective of effective lifecycle management is to ensure continued efficiency and consistent performance of the automation, even as the environment grows and changes. The main function of the automation lifecycle is to support automatic configuration management, easy scaling for both apps and infrastructure, continuous monitoring, and quick adjustments when needed. These practices help keep the BigIP environment stable, flexible, and ready to handle changing needs. We will break down the automation lifecycle into 5 distinct stages: provisioning, onboarding, deploying, operating, and changing. Each stage will explain and provide examples on how to leverage Ansible or Terraform to achieve efficient, scalable, and consistent management of BigIP infrastructure and application services. From the initial provisioning of instances to configuring applications, performing regular operations, and handling changes, we'll explore how to integrate these tools seamlessly to achieve high efficiency and reduce manual effort. Now let's explore each stage in detail. Provisioning is the step where you create BigIP instances. These can run on physical hardware, virtual machines, or cloud platforms like AWS or Azure. To do this in an automated and repeatable way, Terraform is a good choice. It is a declarative tool that uses its own configuration language to define what the infrastructure should look like. You describe the setup once, and Terraform takes care of building it. With this infrastructure as code approach, you can build BigIP instances and related resources using automation. F5 provides official Terraform resources in the F5 Cloud Docs, and there's a supported BigIP provider in the Terraform registry. These tools make it easier to connect and configure your BigIP systems. Terraform makes sure the infrastructure always matches what you've defined by handling the setup and any needed updates. Provisioning focuses on creating the big IP instance and its environment. This includes setting up virtual machines or cloud instances, networking basics like subnets, and assigning IP addresses. It's the foundation layer where the system is made available, but not yet ready to process traffic. As an example, a network team might use a Terraform plan to provision 2 big IP virtual editions in an AWS VPC. These instances can be deployed across different availability zones with defined subnets, security groups, and elastic IPs. Onboarding is the step where the provisioned big IP instance is configured and made ready for use. This includes setting up VLANs, assigning self-IPs, adding routes, and integrating services like DNS, NTP, and licensing. These tasks ensure that the device is fully operational and connected to your network environment. For example, after big IP instances are provisioned, Terraform can use onboarding templates to configure a management interface with a static IP, assign self-IPs to VLANs for internal and external traffic, set a default route, and apply DNS and NTP settings. Licensing can also be automated through the F5 Big IP module. This helps ensure the device is network ready and aligned with organizational policies. Terraform enables this by defining onboarding steps like VLAN creation, self-IP configuration, route setup, and service integration in a declarative way. Using the same templates and modules helps keep the configuration consistent in different environments. By reusing templates and modules, you can ensure that the onboarding process is consistent and repeatable across different environments. This is especially useful when deploying multiple big IP instances or when scaling your infrastructure. The deploy step is when you set up application services on your big IP system. You can use Ansible to automate this part. Ansible lets you define the setup in simple files called playbooks. These playbooks describe what needs to be done, and Ansible follows the instructions. Ansible is highly effective at managing configurations at a granular level, giving precise control over every aspect of the deployment. F5 provides officially supported Ansible collections for big IP, which include ready-to-use modules to manage virtual servers, pools, monitors, and other key features. For example, you might use Ansible to deploy a virtual server with a pool, attach a health monitor, and apply profiles for SSL and compression. This setup can be used for many applications without repeating the manual steps. Because playbooks are repeatable, the same configuration can be used across different environments. This saves time and avoids mistakes. The operate phase focuses on the ongoing management, monitoring, and analytics of the big IP system. Ongoing operations require monitoring and analytics to ensure optimal performance and reliability. This stage leverages external monitoring tools, F5 telemetry streaming, and BigIQ to gather metrics and operational data. F5 telemetry streaming enables Big IP to plug into telemetry pipelines to share desired metrics and data, providing valuable insights into system performance and health. Additionally, BigIQ centralizes management and monitoring tasks, making it easier to maintain and operate Big IP systems at scale. The change management phase means making updates to Big IP settings so they match new or changing needs of the application. Ansible is useful here because it lets you apply these updates in a controlled and automated way. Ansible playbooks make it easier to apply changes step by step, helping avoid mistakes and keeping systems consistent. When an application needs to scale, both the application settings and the infrastructure may need updates. Ansible can adjust the configuration to support more users, while Terraform can handle the creation of new Big IPve instances. For example, during a traffic spike, a pipeline can be triggered automatically. First, Terraform launches new Big IPve instances in cloud and places them in separate availability zones. Then, Ansible updates the Big IP configuration to include the new instances in the load balancing pool. This combined automation helps manage traffic without needing manual steps. Using both Ansible and Terraform together lets you adjust both the application setup and the infrastructure at the same time. This helps keep everything running smoothly even when traffic or requirements change quickly. Integrating multiple automation tools for different stages of lifecycle management could bring increased flexibility, especially if consolidated into an automation toolchain to provide the best of both worlds for declarative and imperative configuration. For example, in provision and onboard stages, Terraform is used to create and configure essential infrastructure components like virtual machines, network interfaces, VLANs, and IP settings. At the same time, in the deploy stage, Ansible takes over to set up and launch application services on big IP. In operate stage, we focus on monitoring and analytics. Ansible can be used to manage the configuration of monitoring tools, such as F5 telemetry streaming and BigIQ, which provide insights into system performance and health. Change stage is where the two tools work together. Ansible handles application-level changes like updating configurations or deploying new services, while Terraform manages infrastructure-level changes, such as scaling infrastructure or modifying network settings. By combining Terraform and Ansible in your IAC strategy, you build a reliable and efficient automation system that helps maintain your big IP environment with less manual effort and more consistent results. To sum up, automating the F5 big IP lifecycle using Ansible, Terraform, and infrastructure as code IAC significantly improves efficiency, consistency, and reliability. These tools work together to automate the entire process, from provisioning infrastructure to deploying applications and managing ongoing operations. This approach reduces manual intervention, minimizes errors, and enhances performance by leveraging automation best practices. By implementing a well-structured automation strategy, organizations can achieve faster deployments, seamless scaling, and better resource utilization. Monitoring and analytics also play a vital role in maintaining system health and detecting issues proactively. Overall, using IAC with Terraform and Ansible not only modernizes the management of big IP environments, but also prepares them for future scalability and operational challenges. Automation improves reliability by making deployments repeatable and error-free. Testing and validation processes can also be automated, ensuring that changes do not introduce new issues. Monitoring and analytics tools further help to maintain system stability and quickly detect any problems. This chapter covers the tools and approaches to help you manage and monitor your big IP environment before, during, and after infrastructure or configuration updates. Comparing performance before and after making changes helps identify possible problems and also measure the impact of your updates. We'll cover Big IP iHealth, BigIQ, the AST tool, external monitoring tools, and external logging tools. Let's get started. Big IP iHealth is a tool that helps you check and fix your system's configuration and performance. You begin by uploading a user configuration set file to the F5 iHealth website. The site looks at the file and gives you a full report. iHealth shows you setup problems, ways to improve performance, and possible security issues. It compares your setup with F5's known issues and tips to help keep your system running well and safe. iHealth gives you clear reports with details, advice for fixing problems, and any risks it finds. A helpful feature is that it can track setup changes over time. This lets you see how changes affect your system. You can compare the current setup with older ones to find problems or changes. iHealth can collect data from many big IP systems. This gives you a full view of your setup. It helps you find problems that happen across different systems. iHealth works with automation tools like Ansible and Terraform. For example, you can set up a system where a UCS file is sent to iHealth every time a new setup is deployed. This helps catch problems right away. With Ansible or Terraform, you can also create and get iHealth reports automatically. These tools can look at the reports and find known issues or risks. If they find a problem, they can take steps to fix it automatically, like undoing changes or sending a message to a responsible person. Next, let's talk about BigIQ. BigIQ is F5's tool that helps you manage multiple big IP devices from one place. It makes it easier to control configurations, monitor applications, and automate routine tasks. You can see how your devices are performing and check security settings through a single dashboard. This saves time and makes troubleshooting faster and easier. One helpful feature of BigIQ is that it lets you set up different user roles. This means each person can get the right level of access without giving full control to everyone. You can also use APIs to automate tasks and connect BigIQ with tools like Ansible and Terraform. BigIQ works well with automation. It acts as a central place to manage settings and policies across your devices. For example, you can use an Ansible playbook to create a new device group in BigIQ, assign a configuration template, and deploy it to multiple big IP devices. Terraform is often used to set up the BigIQ system and connect it to BigIP devices by defining the infrastructure and network settings in code. These tools work with BigIQ's version control features to keep track of changes. After running your automation, you can check the BigIQ dashboard to confirm that updates were successful. If anything fails, you can roll back to the last known good configuration. BigIQ also helps with logging and telemetry. It collects logs from all your BigIP devices and shows them in one place. This makes it easier to spot problems and keep track of security events. You can see real-time data about how your devices are doing. Another helpful feature is license management. BigIQ makes it easy to track and update licenses. You can save and version your settings so you can go back if something goes wrong. For security, BigIQ works with other F5 tools like ASM and AFM to manage policies and get threat data. You can also set up automatic backups to keep your settings safe. It doesn't matter how many devices you have. BigIQ can handle large environments and make your job easier. The AST tool, or Application Study tool, helps you see how your applications are working and how traffic moves through your F5 systems. It pulls data from many places and shows it in a clear dashboard. This makes it easier to find where problems are and what to fix. AST includes three main components: OpenTelemetry Collector, Prometheus, and Grafana. OpenTelemetry gets detailed data from BigIP devices using iControl REST. It collects traffic patterns and system health from across your setup. Prometheus stores this data over time. Grafana takes that data and shows it in charts and graphs that are easy to read. AST supports F5 BigIP automation by checking what happens after scripts and changes are deployed. You can link it to CI/CD workflows. After a change, AST tracks traffic, latency, and errors. If something goes wrong, AST can help trigger actions like rolling back a change or adding more resources. AST is especially useful for Day 2 operations, which means running and maintaining your environment after the first setup. You can see how traffic and API usage change over time, and compare performance before and after automation scripts run. AST helps you know if a change from a Terraform plan or Ansible playbook caused a slowdown or changed system behavior. Grafana dashboards are open source, so you can change what you see based on what matters to you. It also fits into production setups, with features like high availability and login security for Grafana. In F5 BigIP automation, AST gives you a way to watch and understand the results of your changes clearly, using tools that are simple and built to scale. Let's talk about external monitoring tools and how they help with BigIP. These tools give you important data and alerts so you can keep your system healthy. They let you track system activity and spot problems early. With monitoring tools, you can check if CPU or memory are being used too much. You can also watch network traffic and connection counts to see if something looks unusual. You can set alerts to warn you when performance goes past certain limits. They also save past performance data so you can see trends over time. There are two kinds of tools: commercial and open source. Commercial tools, like Datadog, usually come with dashboards and built-in alerts. They are easy to use and provide full tracking. Open source tools, like Prometheus and Grafana, are more flexible and cost less. They work well for teams that want custom setups and more control. These tools are very useful for automation. During deployments, they give live feedback. For example, if Datadog sees high CPU use on BigIP, it can send an alert. This starts a workflow with Terraform script and adds more BigIP instances to balance the load. This keeps your setup running by automatically adding resources when needed, without manual changes. Once the system goes back to normal, Terraform can remove the extra resources. This saves money and keeps performance stable. Using monitoring tools like this helps you react fast and keep things running without manual work. External logging tools help track changes and issues in your BigIP system. They collect logs from all devices and show them in one place. This makes it easier to find problems, check system behavior, and respond faster. For example, if a virtual server fails after a Terraform deployment, you can check the logs to see what changed. If a security rule is updated with Ansible, the log shows who made the change and when. Popular tools like Splunk, Elasticstack, and Grafana Loki work well with BigIP. They show real-time logs and help connect data from different sources. Commercial tools offer advanced features such as built-in alerts, dashboards, and support. They are easy to integrate and scale in enterprise environments. Open source tools are free to use and give you more control. They may need more setup, but they work well if you want a flexible and low-cost option. Logs are useful before and after automation. Before automation, you can review the system state to make sure it's ready for changes. For example, checking logs can show if any recent errors or changes might affect the automation. This helps avoid failed runs or unexpected results. After automation, logs confirm whether updates completed as expected. They can show if a new pool was added, if a virtual server setting was changed, or if any errors occurred. If something went wrong, the logs give you a clear starting point to fix it. They also help verify that your changes matched what the script was supposed to do. You can also use logs to trigger an automation workflow. For example, if a pool member is marked down, a log entry can launch an Ansible playbook to replace or restart the node. To wrap up, this chapter explored tools that help you manage and monitor BigIP before, during, and after making changes. BigIQ helps you manage many devices from one place, and the AST tool shows how applications are working and where problems might be. Logging and monitoring tools let you see system activity and alert you to issues whether you have a few devices or many. When you connect observability tools with automation tools and workflows, your setups become more reliable and easier to manage. Logging, real-time checks, and automatic issue detection help your team act quickly when something goes wrong. This keeps your BigIP system stable and makes sure your updates do what they are supposed to do. Thanks for watching. Make sure to check out other videos in this series,